Okay, hello everyone, and welcome back. We're starting probability today. Okay, it's a very important concept, probably the most important thing we'll cover during first trimester. All right, how likely it is for an event to happen. Guys, today's objective, to define and find different probabilities. All right, it's just our introduction of probability. Today's essential question: is there a way to measure how likely it is for an event to occur? Is there a way? Well, it turns out there is. It's probability. It measures how likely it is for an event to occur. All right, probability, it can be a percentage between 0 and 100%. Or it can be a number, 0 through 1. In other words, probability is often a decimal or a fraction if it's represented as a number. Or again, a percent. It can't be more than 100%. 100% means absolute certainty. Turn this. Guys, the first thing we're going to talk about is experimental probability. And that's when you gather data from some observations. You do some trials. All right? You collect some data from some results. All right? So the probability, the experimental probability of something happening, a particular event, is the number of times that that event occurred as you did the trials over the total number of trials. Okay? Even though we know maybe heads and tails is 50-50, when you calculate experimental probability, always use the results you got. Guys, sometimes actual results are difficult to conduct, and we want to get sometimes a huge sample size that might take a long time. We can find experimental probabilities using a simulation, which we model, one or more events, and then simulate what happens. We use experimental probabilities because sometimes we don't know the probabilities. So we sample to try to find out what happens. Guys, when you roll a numbered cube, a dice, the possible outcomes, there's 6 possible outcomes. All right, the other probability we're going to talk about is the theoretical probability. Now, you know how many possible outcomes, and you know what the outcomes are. So you can calculate the theoretical probability. Again, n is all the likely outcomes. That goes in the denominator. M is how many times the outcome you're measuring occurs. The event you're interested in measuring, how many times did that occur over the entire of all the possible outcomes. Okay, guys, the probability of an event A happening, we usually write it like that. All right, P, the probability of A happening inside parentheses. Guys, there's something called the complement of an event. The complement of event A, we write it like this. The probability of event A happening with a little dash like that. That's the complement. All right, the complement is all the possible outcomes that are not the event. All right, when you add them together, you always get 1. When you add together the probability of an event plus its complement, you get 1. So you can calculate one or the other of those by taking 1 minus the other. And we'll do that here in a minute. All right, a bunch of examples here. If you roll a dice once, what's the probability of landing on 2? Well, there's only one way to roll a 2, and there are 6 possible outcomes. So it's 1 over 6. All right? 0.17, it's around 17%. That's the probability of rolling a 2 one time. All right, if you roll a dice once again, what's the probability it will not land on 4? Land on everything except for 4.
That's just a reminder that there is an avid site.
Okay, sorry about that. We had an announcement. Again, not rolling a 4. Rolling a 4 is 1 out of 6. So if I just take 1 minus 1 over 6, I get 5 6, of course, which is about 83%, which makes sense, guys. Okay, there are 5 possibilities of not getting a 4. A 1, a 2, a 3, a 5, and a 6. Okay? All right, example 3. You flip a coin 40 times and you record 22 heads. What's the experimental probability of getting heads? See, we know the theoretical probability of getting heads might be 50%, 50-50. But what's our experimental probability based on our results, based on the trials? All right, 22 over 40. All right, that's 11 over 20, that's 55%, roughly. Okay, well, I guess it is 55 exactly. All right, example 4 is important. We're talking about a jar with marbles. All right, 30 red, 50 blue, and 20 white marbles. If you pick one marble from the jar, find these probabilities. The first one here is, what's the probability that you pick one that's red? Well, the total number of marbles is 100. 30 plus 50 plus 20, it's 100. That's the denominator. And of those, 30 of them are red. So 30 over 100, 3/10, or 30%. All right, the probability of picking a blue marble, again, the denominator is 100. There are 50 blue marbles. So it's 50%, 5 out of 10. All right, it's the same jar with the same marbles in there. This is example 4. What's the probability that it's not white? All right. Well, the white marbles, there's 20 of them. So 20 over 100, that's how many white marbles. So 1 minus that. All right, 1 minus 1/5 is 4/5. It's 80%. And notice that's the same as the probability of red or blue. Red or blue, you add up those two numbers, and we'll get more into that later on. All right, there are 30 red marbles and 50 blue. You add those up, you get 80. So red or blue is 80 over 100, or 4/5. And of course it is. Those are the ones that are not white. So you're going to get the same percentage, 80% probability that something is not white, a marble is not white, versus a marble being red or blue. All right, that's it, guys. Remember, probability is a ratio. It's a fraction, where the numerator is some subset of the denominator. All right, these are today's vocabulary words for the warm-up: experimental probability, simulation, theoretical probability, and complement. So know what those are. All right, that's it, y'all. Thanks for listening.